Good day, welcome to the Math Salon. My name is Dr. Numendem. Today we are going to look at two advanced level questions on integration. So the first question says find the area of the finite region bounded by the curve y equal to x into 2 minus x and the x-axis. It's always important that in order to be able to solve problems like this that have to do with graphs, that you can make a sketch. So I'll try to make a sketch here. So let me say this is my x-axis. That's the y-axis. In order to know the points at which this function goes to 0, which will be the roots of this equation, we can say this 0 is equal to x into 2 minus x. If you solve this, means x is equal to 0 or x is equal to 2. If you solve this well, so x is equal to 0 or 2 minus x is equal to 0, and if you solve that, you see x equal to 2. So 0 here and 2 there. If I open this up, I get 2x minus x squared. Because the coefficient of x squared is negative, that means it's a maximum function. So it means it's going to go up like this. Excuse me. And that is the area I'm supposed to look for. The area between the curve and the x-axis. This is my curve. Y is equal to x into 2 minus x. And that is the x-axis. In order to get this area, it is just by integrating. So this is a continuous function. We integrate from 0 to 2. So that area will be equal to the integral from 0 to 2 of the function x into 2 minus x dx. This is equal to, I'll open this out, from 0 to 2. 2 times x is 2x. X times minus x is minus x squared dx. If I integrate this, you know the integral of x to the n is integrated as x to the n plus 1 divided by n plus 1. So if I have to do that, I can also do that here. So this is going to be 2 multiplied by x to the 1 plus 1 divided by 1 plus 1. So that's 2x to the 2 divided by 2. And this will be x to the 2 plus 1 divided by 2 plus 1 minus x to the power 3 divided by 3. And that is from 0 to 2. It's a finite integral. So here we are left to substitute the upper limit minus the lower limit. If I do that, then I get 2 here. The 2 cancels. So 2 squared minus 2 to the power 3 divided by 3. Minus, if I put 0 here, this is 0, that is 0, so that is 0. If you simplify that, you get 4 here, minus that is 8 on 3. To arrange it where the LCM here is 3. 3 divided by 3 is 3 times 4 is 12. Minus 3 divided by 3 is 1 times that 8. So that's going 12 minus 8 is 4. So that is 4 on 3. The second question says, find the general solution of the differential equation, this, given by that. This is a nice differential equation. I notice that I have two variables here, u and t. So one of the key techniques of doing this is, this is the first order differential equation, and I can actually separate the variables. So we apply method of separation of variables. That means taking all variables together. So I will take the u's on one side and the t's on the other side, making sure the mathematics is okay. So du dt plus u plus 1 divided by t is equal to 0. I will take this to this side, then I get du dt is equal to minus u plus 1 divided by t. I will try to take dt this way and divide by u plus 1 so that all the u's are to my left and all the t's are to the right. If I do that, then I get du divided by u plus 1 is equal to minus 1 on t dt. The minus is the minus that is there. And this 1 on t because I took this down. So 1 is remaining there. So I can now integrate both sides of this. If you differentiate u plus 1, you get 1. Because this one will be 0, this will be 1. If you differentiate t, you get 1. I can also put the minus outside. It's just a constant. But you should also know that the integral of a quotient where the derivative of the denominator is equal to the numerator is simply the natural log. So this means this is the ln plus 1 of that is equal to minus is outside, the ln of t plus a constant term, because this is an indefinite integral, but a constant term, I will choose one. Since all of these have ln, I'll choose a ln of a constant. It's still another constant. And I can write this in a nice form by bringing ln k in front. So ln k minus ln t. If I do this properly, the log of 1 minus the log is the log of their ratio. So that is the case here. So my ln u plus 1 is equal to that. If I take this all to the e, then I drop the ln. And I drop the ln here, and I get u plus 1 is equal to k plus t. If you want to make that nice, u is equal to k over t minus 1. That is it. If you liked it, please remember to give us some thumbs up, subscribe, share with your friends. Also, for those who don't really have phones and so talk with their parents, they can also subscribe and alert you once new videos are uploaded. Bye bye and thank you.